All right, so here's a really quick lesson on geothermal energy. Let's get started. So this is the geothermal energy capacity in units of production. So when you see the very dark red areas, that's greater than 1,000 megawatts per year in 2002 by country. So you'll see there are some countries that do produce a large amount of geothermal power. For example, the U.S., Mexico does as well. Iceland is known for using geothermal power, and you have here some countries in the Philippines and Indonesia as well as New Zealand. And surprisingly enough, Russia does produce some power from geothermal energy. I say that's surprising because I didn't think Russia was really in an area of geological activity. So let's talk about how electricity is generated using geothermal power. So what happens is these are areas where uh, kind of there's heat underneath the ground. As you know, as you go deeper into the earth, it does get warmer as you get closer to the core. And these are areas where that heat is relatively close to the surface. And so, what you can do is you can inject water into these areas of high geothermal activity. Then you can take that water back up once it's heated. It is steam at this point, and it can be used to turn a turbine, which then produces electricity. It's very important, though, that you do re inject that water back into the ground. You don't want to start taking materials out from underground without replacing them, and I'll explain why later in this lesson. So where is geothermal power possible? So this graph, I really liked it because it shows areas where geothermal energy is a possible energy source where you could potentially harness it. And then it shows where there are some actual geothermal plants. So you'll see there's looks like there's some here in Hawaii, which is near a hotspot where you have more lava and stuff rising towards the surface. There's one down here in South America, which is along a plate boundary, several in Central America, a bunch in kind of the southwestern area of the United States, as well as what looks like northern Mexico. One out here in the Atlantic, I'm not 100% sure where that is, and a lot in Iceland, and then look in Japan, as well as areas of kind of Southeast Asia, those island nations like Indonesia and the Philippines, as well as New Zealand. Those are areas that are all along tectonic plate boundaries, which are areas where you're going to see kind of more of these heated areas getting close to the surface. And so you're going to be able to access that energy and be able to produce geothermal power with it. So, what are some of the environmental effects? Well, it can release hydrogen sulfide, which is acidic and corrosive, and is not something you want to come in contact with. And it can also cause subsidence of land. Very quickly, what is subsidence? Well, subsidence is when the land sinks, forms something like a sinkhole, and this can be due to mining or extracting resources. Like when you take out oil and natural gas, then you leave kind of empty space behind that ends up getting filled by the rock kind of falling. Same thing with mining. If you dig down and you take out material underground, then the land above, unless you put some support in place, is going to fall. And then also something similar can happen when you take out groundwater. So you're taking out water, and when you remove it, that is going to leave pore spaces in the rock, which can then kind of crumble, and that can cause subsidence. And so, if you take out water or steam from underground for use of geothermal power, and you don't replace it with something, you don't inject water or steam back into the ground, then that can cause land subsidence. So here's our summary slide. You get pretty decent moderate net energy yield out of this, meaning you get a lot of bang for your buck. You get decent amount of energy for the amount of energy you put in. It's pretty efficient. It's not going to produce greenhouse gas emissions. And if you manage the source properly, it's limitless and reliable. It can have a competitive cost, although I do have on the con side that it's potentially expensive to kind of put the technology in place and build the plant. There's also a limit to where you can do this. For example, Texas is not an area where you could really harness geothermal power. There's the risk of land subsidence. There's also the risk that if you start trying to create a geothermal power plant when you're drilling into the ground that can increase tectonic activity. I have read about some places where they tried to drill for geothermal power and they induced a bunch of earthquakes and they had to stop. And then also there's the possibility of corrosive waste. These are going to be more acidic. Thermal waste, which would be extra heat, or saline waste, which are going to be salts. This is not just table salt. Salts are a chemical compound, and some of them can be toxic. Even table salt in high enough amounts can be toxic. Never eat salt by itself, it will kill you. Don't do it. All right, so that's geothermal power, and we are done.